And I led the initial web team there, which built out the web SDK and a lot of things on our website. Since then, I have started my own venture as a technical co-founder at Voke, where we are redefining, sort of reimagining how work productivity should look like in an AI-first world. So, jumping back to our topic, designing data-intensive React applications. Data-intensive in this context is basically any applications which is dealing with a large amount of frequently changing data, right? This often, the signals of these sort of applications are something which, let's say, is using WebSockets or SSCs or very live sync with other people in sort of synced environments and all, right? So some examples of this sort of applications is collaborative applications like Figma, multiplayer games, video conferencing, project management tools, chat applications, and trading applications. One common thing among all these applications is that they have a lot of things going on at the same time. And often, it also needs to be synced across multiple users who are using the application at the same time, right? If we take the example of a live conferencing app, for example, there is something which, let's say, you could build on top of 100 MS SDK. You have all these people in the call. There is some state on the top, like showing recording going on, showing the current speaker. There are a lot of actions on the bottom panel. And apart from that, you often have collaborative whiteboards. You have maybe quizzes and polls going on in the call. You have a lot of stuff going on. On the front, there are some hidden non-happy paths as well. For example, your internet going away, your device getting disconnected, which also needs to be handled by the application. Beyond those things, there is also when scaling comes into picture, when you have hundreds or thousands of people in the same call, the amount of re-rendering which the UI needs to do or the amount of state changes which often ends up happening slows down and makes the application completely unusable. So these are things which you have to, if you are building an application in this category, these are some of the things which you have to think right from the start. You have to be very thoughtful about these things from the start itself. And you can't be, one of that camp that what does front-end architecture even mean, right? Because otherwise, you would just end up in a state where basically everything would be an utter mess, and you would want to throw off your computer. And basically, the final step, right? So, searching for how do you switch your job. So what do we do about this? How do we fix this? Okay. So this is usually what happens in, this is the general thing. You have a server, you have a client, and they are talking to each other. And for your normal landing pages, for your blog websites, it's okay to just plug in React query, plug in whatever library you want, and just go alongside it, and things will work. But when a lot of data comes into picture, you have to decouple these two pieces. You have to make a middle layer. And even though I'm calling an SDK here, it can just be a folder in your application. It can be a simple package. But you have to decouple these two pieces completely in order to really scale well, build something maintainable. So I'm going to talk more about how we did that or how we built that SDK in the context of 100 MS, obviously. But the ideas and the concepts behind everything we will see is very generalizable. This is something I'm already doing at Voke as well, where we are also building such sort of applications. So having this SDK layer, having this sort of layer sitting in between your server and your UI, speeds up a lot of development after that. What would be the goal of such an SDK? So first of all, at least in 100 MS context, but in general as well, you want it to be app agnostic. You want it to be as decoupled from what choices you make on the UI side, because tomorrow you might want to jump on a new Shiny framework, or you might just want to break your whatever monolith into micro front ends. You want those things to not impact, or you want those things to be as easy as possible. The second goal will be developer experience. SDK would want to absorb as much complexity as it can, and it won't be changed very often. But the app layer, the view layer, that would keep on changing like there will be more frequent commits to that layer, and you want that to be more seamless. You want new people onboarded much easier, better ID intelligence, optimized for Copilot to just predict what you want to type next and all. Right? And the third thing you want is being performant at scale. Why do you want it? Because obviously this is a data-intensive app, and the data is just going to increase with time. And the last thing you would want is a consistent state. So basically, in a video call, if I put myself on mute and if other people are still seeing me as unmuted, it's a bad experience. You want the same state to show up for everyone at the same time, at the moment it is changed. How do we go about this? What insights can we have which helps us build such a SDK or helps us build such a layer? Right? So the first insight comes in terms of what Flux does, basically breaking down things into actions and state. Everything which goes on in such things can be broken down into two layers, which is things we do, which we will call actions, and things which see, which are states. So in the context of video applications, it's basically joining or leaving the room. In context of a Notion-like application, it's writing out a new document. And state is what things are you seeing other people in the room, what the status of a task, right? If we zoom into, let's say, one particular feature of the video conferencing, let's say toggling audio, it's essentially you have a button which shows you, which can potentially have two different states, an unmuted state or a muted state. And you have a toggle action which lets you switch from mute to unmute and back again. Now on the surface, this is basically a simple thing, right? Just use state. What do you have to worry about? But what happens when another components need that state? Maybe you want to show the video state, muted state on the video tile. Or what happens if someone else impacts that muted state? So you might be getting remotely muted. Or maybe your device just disconnects and you get muted. These type of things start coming up for every piece of data you would have in such an application. And if not thought through from the start, it will become that entangled mess where every piece is talking with every other piece. So this is where that SDK part is coming into picture. The responsibility of that SDK is to sort of abstracts away all these actions and all the state management. So the UI sort of depends only on the state, and it doesn't care at all about where the source of the actions are or what other places are using the SDK. It just, every component is responsible for fetching its own state, responding to it, and just rendering. Before we dive deeper into SDK implementation, like what other things are here and what other things are here, let's say beyond Redux, let's see how the application code looks like if you're using something like this 100ms SDK for building a toggle audio thing, right? So here you have two interactions point with the SDK. First is you're fetching the current audio state, which is where you're on mute or not. The second is you're just getting an actions object. And the button is, this basically is your whole button. Like this is the complete implementation. There is nothing else, no other code. Irrespective of what changes your muted state, the button will show the correct state. And irrespective of who else consumes that state, when the button is clicked, everyone will get that state. There is no application layer code beyond this for handling this. So let's jump into the implementation part. Now, beyond Redux, right? Like obviously, Redux you can use, and there would be a lot of intermixing or coupling of things within the app layer. This is basically talking more about building something on top of Redux, or more smarter Redux just for your application. How would you go about it? In case of 100ms, we built this on top of JuiceStand, which I'll come to. But essentially, you can imagine a store as just a client database, client-side database, which is synced across all your users. So this database contains who all are in the room, what are the chat messages in the room, and everything. And it is synced for every user in the room is seeing the exact same state, managed by the server and the SDK combination. So this is built with JuiceStand's vanilla store built on top of JuStand's vanilla store, and exposed through the React layer, and connected to Redux DevTools for debugging, right? If we talk about selectors, okay, selectors are also a well-known concept, just getting a slice of the state, minimized with reselect and fully typed APIs. Two neat things to do here, and which we did to make this just improve the developer experience, was first of all just starting everything with the select prefix, right? So it makes it much easier to sort of have autocomplete kicks in, or have LLMs predict what you want to type when you are typing this down. And the second thing which we did was building curried selectors. So curried selectors means that for cases like this, right, where you want to pass parameters into your selector, you are not basically writing an arrow function there. It's also a part of the SDK. All the functions are coming there, and everything looks in the same way. So okay. And the third part is actions. Store, selector, and actions. On the actions front, you just create a big actions object, and the same developer experience things goes here. It's not wondering about what string to call, which functions to call. You abstract those things away for your application. You make sort of a big actions object with all the functions possible. In this case, in such cases like where a lot of data is going on, there are usually 3 classes of actions. First is UI actions, which are usually a result of user clicking something or user doing something. The second is server actions, which is server kicking you out of the room or something else happening, but started from the server end. And the third is auto-detected actions, more of, let's say, network disconnection, device changes, and those kind of things. All of these things you want to abstract within the SDK with an architecture like this. And in terms of developer experience, obviously, you just have to type actions dot and auto-complete kicks in the ID, and you just makes it much easier for the developer to sort of write code, right? So another thing which comes in very, as you get to scale, as more people as there is more data coming in, is basically a lot of too much state changes going on, like hundreds of state changes per second, which leads to very frequent re-renders and slowing down of things. This is where batching helps. So because all of your state updates are sort of isolated to a layer which is below your app, what we did, for example, with our SDK was we implemented batching in a way where every state update is sort of just queued and not applied immediately, queued for a few hundred milliseconds and then applied, leading to the render of UI, is speeding up every application which is using the core SDK without sort of bothering about those optimizations. So yeah, overall, if for these category of applications, if you foresee, you are going to deal with such kind of thing where there is going to be a lot of data changes across many users, and sync and all needs to be taken care of, I would highly recommend just pick whatever library you want, pick Redux, pick JuStand, and build your own layer on top with such a structure for all the debugging side of things, for the developer experience and all. And if you want to try something like this, 100ms SDK is obviously there. There are some other things like live sync and all, which also follow a similar sync type of model. You can always try. And yeah, this basically makes a lot of future things easier for you. So that is all. Thank you. Feel free to connect with me on Twitter, and yeah, thanks.